I want to investigate the question, if I do the first type of random walk with a for loop and I go n steps, what's the expected distance from the origin? So let me do that in a function. I'm going to call it evWalk1. So this stands for expected value of walk1. And it's going to depend on two inputs. N, that's going to be the input to walk1, and x, that's going to be how many experiments do we do. So first I'm going to do x of the experiments and add up the answers for all of them, and then I'm going to divide by x. So I need some value for the total when I add them all up. That's going to be t. And then for I equals 1 up to x. Okay, because I'm going through the experiment x different times. So for each of those, I'm going to do the same thing. That's why I use a for loop. And now I do t equals t plus walk1n. And so this is almost right, but not quite. What's wrong with it? Well, two things are wrong with it. First, let's remember what walk1 is. Okay, say I do walk1 of 6. Okay, that's not a very representative one. Let's do it again. This looks more representative. So backwards, forwards, forwards, backwards, forwards, forwards. And so the thing I really care about is the 2. I don't care about this whole vector here. So instead of walk1n, I really want just the last entry in it. And I'm not allowed to have these parentheses after parentheses like this, so I have to split it up. So v is going to be walk1 of n. And then t, I add on to that the last entry in v. So in this case, I would add 6. In this case, I would add 2. And then at the end, my output, let me change the name to EV for expected value. EV is going to be t divided by x, total divided by number of experiments. So this is closer to being right. It's still not quite right. Let me check it out and see what is wrong. Say I do EV walk1 of 20, and let's do 1,000 experiments. So I get something very close to 0. Let's try it again. Something very close to 0. And what did I do wrong? Well, I care about how far is it from the origin. I don't care about what's its exact value, so I should have an absolute value here. One way to look at it is it's just as likely to move left as it is to move right. So if I'm taking an average, then that's going to be really close to 0. So to have it not be really close to 0, I use this absolute value. So let's try it again. So that looks better, 3.3.